Welcome, everybody. Great to see you. Thank you for logging in. We're going to start here in about, I don't know, roughly 30 seconds. Glad you're here. It's always great to see so many familiar names. It's also great to see a bunch of new people. If this is our first interaction, welcome. My name is Keith Barker. I'm a double CCIE. Been doing Cisco for over 2 decades and love it. And my goal on this channel is to help people who are studying and working on their Cisco skills, focusing on the entry level, and helping you get there. You can do it. The CCNA will change your life. The skills will change your life. The actual cert is okay too, but the skills and getting going is what will make the difference. All right, I'm going to do a couple quick checks. My mic is on. Good, good, good. You're here. Good, good, good. Let's start this thing off. Let's go ahead and clear my screen. And here we go. This is all about QoS. Again, so glad you're here. This is the July 2021 edition. I think we have 12 or 10 questions, and they're all about 60 seconds each. First one's multiple select. What can place markings on frames or packets for use in quality of service? And choose all the answers that are applicable. All right, all those devices, those entities can place frames, markings on frames and packets. The key with differentiated services is that we're discriminating. That's effectively what that does. So when we talk about PHB, per hop behavior, it means that every device in the path, let's say these are several routers, maybe we have a switch or two in there, and the user is sending traffic, or it could be an IP phone or something else that's going through here, then here, then here, then here, then here, to a final destination. Per hop behavior means that each device on its own is looking at the markings. And if you're a switch, you could be looking at layer 2 markings. If you're a router, you could be looking at layer 3 markings. And then, you know what the router says when it sees the markings? It says, I don't care. Literally, by default, it doesn't care. Because unless you've also trained the router to do QoS and to give preferential treatment to some types of packets. So there's some bits in the layer 3 header. They're the DSCP bits, IP precedence bits. They're the same bits, precedence. And based on those bits, if they're in a certain value, the router can say, whoa, if there's congestion, and based on who has the right markings in the IP headers, I'm going to give that traffic preferential treatment. Think of it like a huge line, and everybody's in this room, and everybody wants to get out. And these are packets. So let's say there's thousands of packets in this room, and they all want to be forwarded. Well, if there's enough bandwidth, we don't need QoS. We just send it all as fast as we can. If it's not a problem, great. QoS really comes in handy, though, if there is congestion. And then the question comes in, okay, what do I do? First in, first out, which is a default on many Cisco interfaces, or do I have a QoS strategy, which based on the markings in the packets, am I going to give preferential treatment? And so I've got a video in my library here on YouTube. It's absolutely free. It's called, if you do a search for Keith Barker QoS, it covers all the elements from the blueprint. And that's this bad boy right here. Let me bring it up real quick. It covers everything from 4.7 in the blueprint. Explain forwarding per hop behavior. For QoS, it's just classification, marking, queuing, congestion, policing, and shaping. And so if you are new or you just need a refresher, that one video covers all of 4.7. So make sure you make some time for that. All right, here we go. That's question number 1. Here's question number 2, and then we'll take a look at the leaderboard after that. Question 2 is this. Which QoS mechanism is prone to starving out lower queues? Meaning if there's stuff in the higher queues, the lower queues will never get forwarded. Which one does that? Priority queuing isn't used too much anymore by itself, but absolutely it will starve out the lesser ones. So let's imagine that we have a room. And whenever I think of with QoS, I think of a room full of packets. So let's give you a room full of people if you want for that analogy. That works too. And they all want to get out. So they all have an urgent need to get out so they can get on to where they're going. I mean, life is short. They want to get where they're going. So if we have a room and we have lines. We have line number 1 and line number 2 and line number 3 and line number 4. Let's think about how we could get these lines of people out the door. Now, a fair option would be to say, let's take somebody from line 1, 2, 3, 4, go round robin. That might work, and that'd be actually kind of fair. But that's not how priority queuing works. Priority queuing says this: is there anybody in line number 1? Yes? Great. Go, 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 go. And then after this line is being moved out, it then goes back to this line. If somebody else stepped into that row, that queue, it's going to say, oh, there's somebody else in this queue. Go ahead. And it's only when this queue number 1, the highest priority queue, is empty, where it even checks with queue number 2. And then after it moves one person out of queue number 2, it then goes, checks and says, hey, is there anybody new in queue number 1? So queue number 1 is always going to be serviced first, unless it's empty, and then queue number 2. And if, and only if, queue number 1 and 2 are totally empty, then does queue 3 get a chance. And if queue 1, 2, and 3 are totally empty, queue 4 gets a chance. And if there's congestion, which is when QoS comes in really handy, and there's lots of traffic that needs to get out of the firewall or out of the router, either way, queue number 4, a lower priority queue, will go hungry. Bow, bow, bow. And that's why it stinks to be in a low priority queue. And we don't often use that by itself anymore. We use other mechanisms that are more fair, but still give advantage to those applications that need it. Okay, let's see who's on top. Ooh, power squid. Oh, yeah. Gentle hare, tropical koala, speedy turtle, and prairie snail. All right, we've got, I think, 8 questions to go. Here we go. Question number 3. It's a word cloud. I'm curious. What is the one thing that you can change right now to help you reach your goals? Take a moment. Let me know. All right. Well, my suggestion as a friend to you is whatever it is that's holding you back right now, something that's in your control. I know there's a lot of things that are not in our control, but whatever it is that's in your control, I'd like you to just take that one thing and focus on it and see if you can improve it. For me, in my life, there's 2 or 3 things that I just know that if I stop doing them, they're time suckers. I will do better with my other things. So whatever that is for you, my coaching and my plea with you is to please do it. Take action now. It's worth it. It's worth it to do a few hard things now and put off some easy things, and your future can be brighter as a result. So thanks for that feedback. That was a no pointer, but you know what? It can make the difference for you if you change that one thing. I believe in you. You can do it. If I can get a CCIE or a couple of them, you can get a CCNA and beyond. All right, here's the question. HQ, the headquarters site, has a 1 megabit per second WAN link, and the remote sites, plural, only have 256K links. Which QoS mechanism would be appropriate for this? It indeed is shaping. Policing in the world of QoS is all about no. For example, your traffic shall not go above 1 megabit per second. However, it's going to go ahead and kill everything above that. Oh, that's MPS. What the heck is MPS? Megabit. Let me change that. Mega, lowercase b, per second. There we go. So policing is all about saying, hey, if you go above that, I'm just dropping the traffic, boom, killing it into the bit bucket. That's a bit bucket right there. So why wouldn't we want to just, if we had a headquarters site and we had several remote sites out there, WAN sites, why wouldn't we want to just delete the extra traffic? It's because we care about the traffic. We don't want to delete anything, but we also need to slow the traffic down, and that's what shaping does for us. So traffic shaping, QoS shaping is about queuing up and slowing down the traffic, but we're not dropping it, where policing, once we get above a certain limit, it's going to go ahead and just do a drop. Also, I know QoS is super exciting for everybody, or at least for some. And if you have specific questions about any of these questions, let's go ahead and take those in the Discord server, which is free. It's right. We'll do it right after this live quiz. And there's a link in this video description. So if you want to join me there in the CCNA voice room for, I don't know, 20 minutes, 30 minutes, I'd be more than happy to talk about any of these questions and answer those for you if you have them. Also, I would strongly encourage you, if you're new to QoS, check out that one video that covers all these details as well from me and my channel. All right, here we go. Leaderboard, Power Squid, 5,670, followed by Tropical Koala, Gentle Hare, Speedy Turtle, and Purple Wallaby. Congratulations for everybody who's participating today. Here is question number 5. It is multiple select. What are the primary benefits of WRED, which is weighted, random, early detection? All right. It is indeed drop some low priority traffic, not all of it, and also avoiding congestion. Let's take a look at this picture for a moment. Let me grab a pen. So I think we could all agree that there's some congestion here. And what happens in the world if we have a lot of TCP traffic, which in many environments we do, when a client is talking to a TCP device or using TCP to communicate, they have a window size And as things go great, that window size, the number of segments at layer 4 that they can send without an acknowledgement, it increases and increases and increases. But when they start losing segments of data, meaning, chunks of data, they're going to shrink that window size back down. So what happens overall is our traffic, when we start having congestion, is the window size is going up for everybody who's using it. And then we start losing segments of data, and then boom, everybody kind of backs off. And then things are going great again. It goes up, and then they start losing data, and the window size goes down. And they call this the sawtooth effect because it kind of looks like, the teeth of a saw, which is bad. So the reason it's really bad is because all this space here, all this bandwidth, is not really being utilized, and it's not a reliable network. So with weighted random early detection, what we can do is we can identify. Let's go ahead and pick some cars as an example. Let's pick any car. Any vehicle that's not a van or like a transport. It's like just a small compact car. So if we took those small compact cars, like this one, this one, this one, you get the idea. And we said to all there's a motorcycle. Is that a motorcycle? Wow. What is that there? I don't know what that is. But if we took all those and said, hey, you're not as important as the other traffic, so we are going to just remove you from this scenario. Oh, that's one too. That's one too. Our goal is to remove enough of the noise so that the most important traffic doesn't have to have a hit. And so what a router is doing, if it's implementing WRED, it's looking at the layer 3 header and the bits there. And so there's some bits that are called the differentiated services code points or IP precedence. What is it called that? And I'll show you a capture a little bit later here. So those bits, if like they're this, how many are there? 6, 1, 2, there you go. So if they're like that versus this, the router, if it's trained to look at it, which they're not by default, but if they're trained to look at those bits, would say, whoa, I need to go ahead and forward all this traffic. And then I'm randomly going to pick traffic that has bad bits or not as good bits in the IP header for the IP precedence and drop them. And it does it randomly, so we're not really discriminating against the same same exact traffic flows every time. But our goal is to take out a few for the benefit of all. And I also want to point out one more time that QoS is not really important. What, Keith? What are you saying? QoS isn't important. It's not important if you have the bandwidth. If this is the queue, the line, and it's never full, where the router can just forward traffic. If this queue is never getting backed up, we really don't have a need for QoS. Because the router can send everything. Yesterday in the office hour, somebody asked me about setting up priority traffic flow for like one IP address. But the thing is, you have to find out what that IP address is, and then to implement QoS, it's done with the modular policy framework, or at least that's how we did it in the old days before software defined everything. And it would go like this. We'd use a class map. And a class map identifies traffic. Think of a class map like saying, okay, I'm going to pick on all of a certain type of traffic. So a class map says who we're going to identify. And then we have a policy map. There we go, policy map. A policy map says, what are we going to do? So the what is huge. I mean, the what we're going to do to traffic is we could police it, we could shape it, we could prioritize it, we could use options inside of low latency queuing. So the policy map says what we're going to do, and then the service policy is where are we going to do it? What interfaces are we going to apply this to? Or you can apply it to the control plane for control plane policing and other features like that. So those are the 3 options, or the 3 building blocks for implementing QoS if you're going to do it manually at the CLI, which is how our forefathers did it for decades. And so let me also bring this back to CCNA. In CCNA, they're not going to ask you about implementing QoS. They just want you to be aware of it and the options for it, like we mentioned earlier. And then as you get into CCNP and CCIE topics, then you can start looking at the details for how to classify traffic, identify what you want to have happen to that traffic, and then apply that policy. And the benefit in CCNA is that we have a topic about lists, access lists. So standard access list, extended access list. And in CCNA, we talk mainly about applying those for filtering traffic or applying them to an access to the V2I lines to restrict, who can connect, or possibly with NAT, like who can be translated. But it's all building up to bigger things, including quality of service implementation, because we're using lists many times to identify that traffic, or using lists with things like border gateway protocol for manipulating the traffic and the paths. So all the fundamentals that we're learning in CCNA are super important because they all tie in to bigger pictures. So my coaching would be, don't go for the big picture first, go for the fundamentals, learn the fundamentals. And then as you get to the bigger aspects and applying those basics, you'll be better off because you'll understand the basics and the fundamentals. That is true. Yeah, I'm living proof. I'm not the IT guy. I never thought I'd be an IT guy. I fell in love with computers back in the 80s. I'm kind of like the unsuspected success with IT, but I just put in the time and I liked it. I learned a little bit, and I still, every single week, I learn something new, or I see a different insight regarding a protocol or regarding how something works. So yesterday in the office hour, we had a discussion. It was great. Somebody asked about IPv6 static routes, and they shared a topology in the office hour. Join us every Saturday, 10 a.m. Pacific. It's fun. And the question was about IPv6 static routes and some aspects regarding that. And then I think Dan, who goes by Troubled here, he asked about a recursive route or a next hop that wasn't, on the same subnet. And that got me thinking about the other thing. And anyway, it's just great discussions about how stuff really works. And most of what I know is all built on the basics, which I encourage you to master and learn it and then keep on growing. All right. I took a little bit longer than I wanted to on that one. Weighted random early detection drops some low priority traffic, not all of it, and also avoids congestion by avoiding that sawtooth effect. All right. Or hopefully avoiding it. Okay, Power Squid, still in first place. Here we are. Question 6 of 10, multiple select. Phone traffic, like voice over IP specifically, is prioritized over the PC behind that phone. Why? Why is that done? I'm looking for 2 answers here. All right. Marking and classification is absolutely true, especially with per hop behavior. When a device receives a frame at layer 2 or a packet at layer 3, if it's been trained to behave a different way, put that traffic in a certain queue or prioritize it based on how the QoS is configured, that's the reason that that certain traffic is prioritized. So great. And I'd like to just show you something really cool. I think it's cool. This is, let me bring it up a little bit bigger. So here is a small network. I've got a PC up on the left, a PC up on the right, a couple switches, a couple routers, then a cloud of connectivity. Woohoo! And then I've got, I think, an IPsec tunnel going between R1 and R2. But if we capture traffic, let me go ahead and let me do a little. Yeah, let me capture traffic on gig 03. So I'm going to say capture on gig 03. This will be fun. And let me make that bigger. And let me make the font bigger. All right, so many buttons. All right, so here is EIGRP traffic that's being sent. And let's do, yeah, I've got a minute. Let's do this real quick. Let me minimize that. Let me go to this PC real quick. And this PC is a little virtual machine in this lab environment. And for CCNAs, I recommend starting with Packet Tracer. And then as you get to the CCNP level and other vendors, you can use other emulators that basically are a pain to learn. But once you get them going, they're great. But for the entry level, stick with Packet Tracer. But I want to show you this packet capture. So let's go to, not a browser. Keith, what are you doing? I don't want to go. It's going to bring up a browser. I don't want the browser. I'm going to close the browser. There we go. Close that window. Yes, close tabs. All right, let's go to a command prompt real quick. So applications and system tools. Let's go to, there we go. That'll work. Let me go to view and zoom in a little bit there and zoom in. All right, so let's do an IF config. So this is on a Linux box. It's at 10.10.50. That's the IP address of this device. And the router behind it is at 10.1.0.1. So if we wanted to SSH to that device, we'll do an SSH-L. That's for login as. We'll log in as admin. And then we'll put in the IP address 10.1.0.50. Nope, that's wrong address. .1. Okay, and it says SSH connect to host, connection refused. Why? Why would you? I didn't fail a login, so why is that? Let's just take a quick peek. In fact, let me turn off this capture for a moment. And let me close that window. All right, so let's take a look at R1 real quick and just verify why it failed. And this is all leading to QoS, by the way, because I want to show you the IP precedence header, the IP precedence field in the IP header. So this is R1. And let's go ahead and do a show run. And we'll say section line. And that's just an easy way of seeing the line configuration. Okay, so when we connect via SSH or Telnet, we're connecting on one of these logical VTY lines, which is why I'm having the problem. So transport input none. So we'll fix that real quick. Line VTY 0 through 4. It's the first 5 VTY lines. And we'll say transport input SSH. All right, now let's go ahead and try that from the client. So we'll bring back the client. We'll hit the up arrow key. Still refused. Why is that? And let's do a, okay. Let's do login local. So that says when somebody logs into this VTY line, it's going to use the local database, and let's create a user account so they can log in. Username admin, and I'm wondering why the tab didn't autocomplete admin for me. It's because it's not a command, it's just a string. And the secret I want to use is this one. All right, and let's go back and try it again. Okay, still no good. So I must not have SSH configured. So it's a quick rehearsal on that. IP domain name, and you can use dash name or space name. They're both the same command. And we'll call this ogit.com and crypto key generate RSA modulus 2048. Somebody asked me the other day, like, wow, how do you have all these things memorized? I don't. I use context-sensitive help probably more than anybody else, but I've done it a few dozen times, and that's why it comes back. And let's also do IP SSH version 2. And what else do we need? Do show run section line. And let's just take a look real quick. Okay, so login local. I've got the username of admin. I've enabled SSH. All right, let's do a capture and let's try this out. Let me minimize that. And let's go ahead and right click and capture on R1 on gig 0/3. And I'll make this a little bit bigger. It's always great to apply what you know also. So you can learn a concept, but if you just spend a few minutes in Packet Tracer or the emulator of your choice, then you can go ahead and reinforce it. Also, I learned a ton. It's like, well, I wasn't expecting that. Why is that? So let me make this a little bit bigger. All right, that'll work. Okay, so let's go back and test it now again. Let's go back and we'll do a SSH with the -L. That means login as admin to 10.1.0.1. It's saying, hey, I don't recognize this fingerprint. Do you want to connect? I'm going to say yes. And then, oh, yes, yes. And then it's going to ask me to supply my password for admin, which was that bad boy. All right, and we're logged in. Yay! So show users, it's showing that I'm logged in as admin. I'm connecting from this source address of 10.10.50, which is on my computer. Fantastic. And now let's stop the capture in the background. Let me make that full screen. And let's take a look at this output. Boom, 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 boom. Okay, so you're probably thinking, Keith, how are you going to tie this to QoS by this? Let's just grab let's grab an SSH session. Here we go. Here's the beginning. There's our three-way handshake right here. So I'm just looking at the SYN flags over here. SYN, SYNAC, and ACK. So here's our SYN request as part of the three-way handshake for the beginning of our SSL session. So we click on that packet there, and we look at layer 3. We expand it. Look at this right here. In the IP header, right here, it's showing, that's wrong field, this field, differentiated services field. That's DSCP. Look at all the bits. Those 6 bits, see how they're all zeros? That means that if a router was trained to look at those bits on making a decision, which they're not by default, they're just like, I don't care by default, unless you set up a QoS policy, this would not get preferential treatment. But look at this. On the reply back, this is the SYNAC coming back from the actual router. That's also, oh, look, yeah, that's also all zeros. That's not too impressive. Let's go down, though, to the SSH. So this is the beginning of the SSH session now, and it's still zeros. If we go back to the server reply, though, those are zeros. Oh, there we go. Okay. So look at this. Eventually, at some point, this is coming from the router, going back to the PC. Look at that. See the differentiated services code point of 110000? And there has the class selector of 6 and a value of 48. So by default, this router couldn't care less, or the devices in the network don't care about those bits because they're a lot of their default policies are first in, first out. So if we did let me just take a look at the interface real quick. This is the interface right there. So we do a show interface gig 0/3. A lot of information here. I get it. But as far as QoS goes, look at this. Here's the queue. That's the input queue for that interface. Think of that like the line. And we haven't had any tail drops. That's great. Queuing strategy right here. First in, first out. First come, first serve. Limited time offer. So we're not doing any kind of queuing mechanism other than the default first in, first out. So because of that, if the router or firewall, whatever the layer 3 device is, gets traffic in and it's not and it needs to forward that and it's not configured to do QoS, those bits don't matter. This is an example of the marking that we're talking about when we're talking about QoS. So at layer 2, there's marking capabilities if we're on a trunk with COS, class of service. At layer 3, there's marking opportunities with these bits, depending on who you read and what the technology is. They could be called IP precedents or DSCP, differentiated services code point. And then if we go down, let's go to another example. Oh, here's an EIGRP. Now, take a look at this. For this EIGRP message that is being generated by the router, it's a hello message. Look at it right here. And the differentiated services code point. It automatically gave its traffic a higher priority. So that now this is a local multicast, so it's not going to be routed. But the routers oftentimes with control plane traffic and management plane traffic will mark it themselves in the hopes that if there's another device in the path that's paying attention to that, it can get priority services. And also, if we're doing things like weighted random early detection, something with these markings at layer 3 are going to be safer than packets that have markings with all zeros. So that's an example of the application or what the markings are looking for, what the markings are in the world of QoS. All right. And also right after, as I mentioned, after this live stream, I'll be in the CCNA voice room, so we can go ahead and take questions as well. In fact, let me go ahead and I will minimize that. I'll save it in case we need to come back to it later. All right. So let's go back here. So phone traffic is prioritized over. So when the phone is actually forwarding traffic, it's marking it. And then we can also train the switch when it receives those markings to trust those markings or to go ahead and reassign markings. And that way you can help protect against a hacker or somebody else who's just artificially marking their traffic with certain bits in the IP header, and you don't have to trust it. So your switches, your ingress devices don't have to trust that. All right, I took a little longer on that as well. Power Squid still in first place. Tropical Koala, Gentle Hair, Purple Wallaby, Space Bear. Nice work, everybody. Glad you're here. Here's question 7. How can you verify that an existing QoS implementation will support voice over IP. One of my friends that I've known for, I think it's almost 2 decades is Kevin Wallace. And he is just a wonderful human. He's a great trainer, fantastic family man, great guy, great CCIE. He teaches QoS extremely well. And whenever I think about QoS, I can't go too far without thinking about Kevin Wallace. So if you're looking for a QoS expert, he is fantastic. So look him up on YouTube, and he's great. You notice one of the answers here is not ask Kevin Wallace, but he's great. Oh, okay. I got 27 people saying IPSLA. So an IPSLA is an acronym for Service Level Agreement, and it's a way you can actually test. You don't have to guess. So the reason I think of Kevin Wallace is for voice traffic to be successful over a network, there has to be a certain level of latency and jitter, certain maximums that shouldn't be exceeded. And I think the number of 150 milliseconds comes to mind. But instead of just wondering, I wonder if my QoS end-to-end is all set up, if it's going to work, you can just test it. In fact, let's do this. It'll be fun. Let's bring up this. I'm going to go ahead and I'm going to close that capture. We can do it again. So let's imagine, just for grins, and this is also one of my secrets to learning stuff, is that if I learn a concept, take a moment and lab it up if you're able to. So if we're wondering, this piece, let's say this PC is going to be using voice over IP or some other time-sensitive application, and it's talking to this guy over here. Maybe it's peer-to-peer, some video app or a voice over IP app. And we're wondering, is our network going to support it? Now, there's a lot going on. I mean, here, this cloud of connectivity could be anything. It could be the internet, could be something else. And if we know that we need our latency to be, either latency or jitter, well, let's say latency has to be less than 150 milliseconds in order for our voice over IP application to be working. How do we test that? The answer is an IPSLA. So what we do is it takes 2 to party with an IPSLA for jitter. And so what we do is we could configure this device here to act as a responder. And this guy has an interface over here at 10.2.0. What is his IP address? I may have to verify that, but I think it's 10.2.0.2. And then over here, this is 10.1.0.1 right there. And then they've got an IPsec tunnel over this internet because they want security. And so if we wanted to test and set up an SLA, we could tell this guy to be a responder. And then we could have this guy go ahead and send IPSLA probes every 10 seconds, every 5 seconds, every 60 seconds, and verify in measurable terms what the results are. And so, you know what? Let's do it. It'll only take a few moments. Let's just do it. So let me bring up this router. That's R2. And let's make him a responder. So the way we make him a responder, you're gonna like this. First, let's verify our routing. I learned a long time ago, before you set up additional features like IPSLAs or security, or make sure you have basic functionality first, because once you have like 8 layers of stuff going on and it's not working, it never works. It's like, whoa. All right, so this is R2, and he has a route back over to 10.1.0, and there's the tunnel interface at 10.12.12. Great. So he's got connectivity back. Let's go ahead and let's set up an IPSLA responder. The syntax, you're not going to believe what the syntax is. IPSLA responder. I think that's the command. IPSLA RESP. Oh, I see. There's multiple options that start with RESP. There you go. I'll tab it out. That's it. This guy is now willing to respond to SLA probes from whoever. We haven't locked it down to a port or a source or anything else. So let's go to R1. And on R1, let's go ahead and do a configuration mode. Be a good start. And let's do an IPSLA, some context sensitive help. Oh, look at all the options. Lots of options. Let's just go for creating a simple IP SLA, which is going to be entry number 10. And then as far as here, we use some context-sensitive help. Look at all the stuff we can check. DHCP, DNS, FTP, HTTP, ICMP echo, ICMP jitter, path echo, path jitter, etc. Wow, lots of options. For a simple demo, let's go ahead and use this one here, UDP jitter. And then we'll use a question mark, and the person, I didn't quite get the R there. Then the person we're going to be probing against is going to be 10.2.0.2. I should have pinged that first just to make sure it's reachable, but this will tell us either way. A question mark, and then a port number. And I'll use, I'm going to use 6783. That's my CCNA number. And context-sensitive help. Now, this right here says, hey, you can do other details like specify a codec or other emulations, but you can also just press enter. You don't have to put in anything else. So I'm going to choose that. Then from here, we have options. Wow, lots of options. I like options. Let's do frequency. And let's specify a frequency of, I don't know, let's say 5 seconds. So every 5 seconds, it's going to do that. And that's great. So now we have our SLA set up. And now the problem is the SLA is not running. So you have to tell it to start. So to tell it to start, you do IP, SLA, schedule, question mark. Oh, we have SLA number 10. That's the one we created. Question mark and start time. And I'm going to go ahead and just say now. And that will launch it. So you could schedule these to be recurring, to happen every day at a certain time and so forth. I'm just going to have it now for the demo. And then we're done. So we'll do a show. IP SLA configuration. And I can press enter here, and that'll show me all of them. I only have one. I have just number 10 here. But if I wanted to narrow, if I had 20 or 30 that were in place, I could just narrow it down. Here it shows me the target address, which is 10202. Here it shows me the port. All right, there, the port. And it's going to happen every 5 seconds. And great. And so if we want to see the details for that, we'll just show IP SLA question mark. Oh my gosh, so many options. Statistics will be great. So here's the statistics for that. And if we look at the details here, there's our round trip times. Here's our latency information. So it looks like as far as latency is concerned and jitter is concerned, we don't have to guess. We can know right here and see right here what the latency and the jitter is. And that way you can verify end-to-end QoS, at least at this point in time. And if this was running every 60 seconds, then we could periodically know that there's an issue or a problem. And that's it. IP SLA. Thanks for giving me a moment to go ahead and demo that for you. All right, let me minimize that out of the way and minimize that. And IP SLA, how can you verify? I don't think anybody's going to forget that, though, right? It's like, yeah, I got it. IP SLA, that's how you verify QoS, whether it will support an application. So you test for that application, whether it's video or voice or whatever codecs, encoder, decoder you're using as far as your voice over IP, and then you can know for sure. All right, we're nearing the end here. Question number 8, here it is. Which QoS level should be used on a wireless LAN controller if you're doing voice traffic over your wireless network? Antonia, you're very welcome. I'm glad everybody's here. Thank you. All right, platinum. Packet Tracer has wireless LAN controller support in it. It doesn't do everything you'd ever want to do with a real wireless LAN controller, but it certainly does most of what you'd want to see and work with. So if you haven't practiced yet, please feel free to do that. I've got a few labs at the Keith, like 30 labs for Packet Tracer at thekeithbarker.com. You can check those out. They are all free as well. All right, we've got 2 more questions. Here is question number 9. Which QoS method delays but does not drop the traffic? The faster you answer, the more points you get, if the answer is correct. All right. This is the same question we had earlier about the headquarters site and the remote sites that has lower bandwidth. It's shaping. When you have one side that has tons of bandwidth and the other side doesn't, you don't want to drop the traffic, but you do want to slow it down so you're not overwhelming the other side. Because if you're, all right, moving on. Last question, here it is. Right after this quiz, we'll be in the Discord server. On my Discord server, there's a link in the video description. And if you have questions that you'd like to ask about these questions we did today or general QoS questions, feel free. I would like to focus on the CCNA level. Also, if you're new to QoS, I would encourage you strongly to check out that QoS video on YouTube on my channel first, as it will answer. Basically, somebody who's watched that video is going to know all the answers to this quiz that we just did today, and also better understand it, which is the real driver. Last question. With per hop behavior, PHP, a single device misconfigured is all it takes to ruin, to wreck, to trash your QoS. Is that true? Or is it false? Absolutely true. Absolutely true, because it's not like it's a lot like a team. In sports and things, there's a team of people. Let's say we have 4 people in the team. Well, if these are all routers and switches, they don't know about what the other devices are doing. So that's why when we implement QoS, if we want priority treatment on certain classes of traffic, with certain markings, we need to make sure that configuration is the same on all these devices, because each hop looks at the packets. If they have congestion, then they're going to basically turn and give priority treatment or shaping or whatever the QoS mechanism is regarding the markings on that traffic. So once that happens there, then the traffic shows up here, and this router 1, 2, 3, 4, router 3 has to make those same decisions, 2 has to make the same decisions. So all it takes is one device where you have congestion on the network, where you don't have enough bandwidth to go around, and this guy can prioritize voice, this guy can prioritize voice based on the markings, and this guy sees the traffic, is first in, first out, and it all goes to heck right there. Because this guy's like, I don't know, first in, first out, so I'm just going to send my traffic, as it showed up. And if there's tail drops because the queue is full, sorry about that too. And the priority traffic didn't get sent out first because I am not configured. So all it takes with per hop behavior with QoS, which is what CCNA wants you to be aware of, all it takes is one device to ruin it. All right, let's see how we did. I'm proud of you. Thank you for showing up on this Sunday to do this quiz with me. Here's the podium. Nicely done. Nicely done. All right, and here are the 3 hardest questions that we had with the primary benefit of weighted random early detection. Who can place markings on a packet or frame? Anybody. Anybody who sees that can put a marking on it. Now, you have to have the software to do it, but hackers have the software to do it. They can prioritize their traffic, and that way the edge devices, they need to normally they're not going to trust any markings at the edge, but they're then going to apply the markings based on the type of traffic and what it's doing. And then how can you verify existing QoS will support voice over IP? And the answer to that one was indeed IP SLAs. All right. And let me get a little bit of feedback from you as well. If you would, go ahead and give me a click or two regarding this quiz. If you enjoyed it or got something out of it, that's my objective. I want you to move forward. That's the secret. Keep on moving. Keep on moving. Forward, forward, forward. If you fall back a few steps, no worries. Get up. Keep moving. Keep moving. Keep moving. Keep going forward. And so what I'm also going to do is I'll be in the CCNA voice room on the Discord server in just a few moments. So until then, thank you very much for your time today. If you're studying for your CCNA or just want to keep sharp on the fundamentals, schedule every Saturday, 10 a.m. Pacific time for the office hour, free on Discord, and 11 a.m. every Sunday Pacific time for another updated, modified, tweaked quiz. I think we've done this for over almost a year and a half now, which is a lot of fun. And I'm super glad for all your support and participation. And I look forward to seeing you in the next event, wherever that might be, including Discord here in a few moments. Until then, be well, be happy, be nice to everybody, and good luck on your studies. Bye for now.